Hi again, this is Al. My first thoughts of doing this presentation was to do it in a combination of both package units and split systems. But during the developing of this slide presentation, I realized that I needed to break it up. So with that said, we're going to get started into the package side of this presentation. Again, I always like to point out the valve, and I just want to make sure that everyone that is watching this has either attended or one of my classes or looked at the installation online and the components of the valve. Valve has basically three components: a desuperheater valve, the atomizing chamber, and a low pressure adjustment, which is commonly known sometimes as a hot gas bypass valve, but we don't like to use that term. We like to use it as a low pressure adjustment valve because what we're doing is maintaining the low pressure side of the system. Again, this is just strictly an unloader for fixed capacity compressor, but what you will actually see in here was that you may not put it on just a fixed capacity compressor. I have put it on two-stage compressors. I have not put it on anything that's a modulating compressor, but I had the question raised to me the other day, and it made perfect sense. Again, the benefits is so many that it is my belief every standard unit or every unit could use a RCCD, and it just helps out with the overall lifespan of the unit and just eliminates so many common issues that's within the industry. One of the issues is the short cycling of equipment, and it's not only bad for on the equipment itself, but it's terrible for moisture removal. And I'm not going to spend much time because this training is also in the installation, but it has to run a certain amount of time. The unit has to run a certain amount of time. In future videos, I'll be talking about adjustment, looking where you need to adjust the valve, things like that, adding other products to it, what will make your machine the best it can be. Applications are all over the place, everywhere. This is a fast selection table that I've kind of created for the 410A, the RCCD control. And it's for basically distributors and manufacturer reps, but it can be used by anybody. I'd like for everybody to know what's going on with it. So with that said, we're going to begin this selection process. And the first question out of your mouth to your potential customer, or if you're the person on site, is it a package or a split? Again, we're going to address the split systems separately because there's so many variables there that we will be talking about this for hours instead of a half an hour to an hour. I'm trying to make all of these presentations somewhere between 15 and 30 minutes. It could easily go over 30 minutes. We've determined that it's a package unit. That's pretty simple. Next thing is, what's the size of the package? Now, in this case here, we're going to start out with the easiest one to do. And we're going to start out with a single compressor unit, and we're going to call it a 5-ton unit. And the reason that we're going to start out with a single compressor 5-ton unit, because it's a pretty simple selection on the product that we want to put in there. Now, again, we're not talking about installation. There's a separate video that deals with installation that I highly, highly, highly recommend you to look at. Even if you are just a wholesale house, rep firm, or somebody that is selling it, you need to look at the installation just to understand that along with this valve, you need one ball valve or at the most 2 ball valves on one of these systems so you can isolate this valve out of the system. We find the 5-ton on the selection sheet. That's pretty simple. I've got it highlighted. 5-ton package. We're not worried about a suction riser. We'll be talking more in depth about the suction risers, velocities in the risers, velocities in the horizontals, minimum, maximum, and all that within the presentation for the split systems. But in this case here, we're looking at a 410-3, which gives us roughly 3.5 tons of modulation. It kind of varies a little bit. It's a little bit below that, maybe 3.2 to 3.4. But for the most part, it's 3.5 by the time you take in some other actions that occur whenever this is going on. So with that, now we find the selections of 410-3. This does not mean that you have to use just the 3. You can use anything below it. You can use the 410-2 or the 410-1. You will get less modulation, and normally we'll size it for the most you can get. But if you're looking at that 5 ton, you got a 410-2, you're roughly getting 50% reduction, which is real good. Another thing I tell people is that our selections or our ability can only go down to 2 tons on a package unit. And I ask people, they'll come to me and they'll say, yeah, but what about a 1.5 ton package unit? No, upsize it to a 2 ton package unit. And then you're able to modulate down to 0.5 ton. At a 1.5 ton package unit, we can modulate to 0. Now, a huge difference between this unit and the APR valve is we can actually run this down to 0 capacity because it's a flow-through valve and everything's flowing through it. We've done it. We tested it. We actually put a 410-3, which is doing about 3.5 tons on a wall-mounted 4 ton on a wall-mounted 3 ton system, and shut the indoor blower off and tested it and let the blower stay off for hours upon hours. And we had complete flow through with no ill effects on the compressor or anything within it. So now we're going to move on. We went up a scale. Now we're looking at a unit that's 2 stages, and it has 2 compressors, but they're on the same circuit. I'm sorry. This is where I made my changes. Now we're looking at a unit that is actually a 2-stage compressor and with a single 2-stage compressor on it. Now, whenever you're dealing with the 2-stage compressor, this unit happens to be 6 tons and the compressor happens to be 6 tons. And I made that probably for simple fact that I'm trying to keep it simple for myself. But normally a 2-stage compressor will do about a third reduction just in a step. So that means that when the compressor is unloaded, the capacity is at 4 tons. Now, I had a whole bunch of these 2-stage units on a bunch of medical buildings throughout the South and up into the Northeast and down in the Southeast, that it just wasn't enough to control capacity. So what we did was, where do we start for the capacity? Well, we have to start at the 4 tons. And the reason we have to start at the 4 tons is because that will, that's the minimum. That's the bottom where we're at now. So again, we'll go to our selection sheet. We'll find a 4 ton package unit, and you'll see it there. And with that 4 ton package unit, we can put a 410-2 on it. It gives roughly 2.5 tons of modulation. So we're back down to about a 1.5 tons or whatever we got there. So we actually have good modulation all the way from a 1.5 tons to 6 tons, which is tremendous. The size of 410 give you 2.5 tons, putting down to about a 1.5 tons. Now you have a variable capacity unit from 1.5 tons to 6 tons. That air capacity and some other things that you can do, you can really fine tune this system into whatever you want it. Now we're going to look at frequency drives. Normally, I used to say, if you got frequency capacity reduction, there's no need, but I had to change my mind. And the reason being is that the frequency drives compressors have a bottom, and this is due to the oil delivery to the top bearing inside the compressor. Limitations range from 17% to 45% for the bottom end. All of this is due to that oil delivery to the top bearing. This has nothing to do with oil coming back from the system. When somebody puts a frequency drive on any system, any compressor, that is not oilless, you need to be aware of this. You can't have a soft start because you're starting a compressor without any oil going to the top. You can't go down past certain amounts. Now, from personal experience, the 45% is that a company in, I believe it in Nebraska or something, promoted adding frequency drives to compressors. I don't think they're even in business anymore, but they put it on standard units as a package. And oh yeah, it saved energy, but at 45%, they went way down past that. And you have that issue, and this comes straight from Copeland. And actually, there's a bulletin that you don't go past 45%, I should say 45 hertz. I got that labeled wrong. It's 17 hertz to 45 hertz. And you don't go past 45 hertz, which is roughly 25% of the unit. Now, you'll also see these units where they'll ramp them way up there to 90 hertz or even higher. And whenever you ramp them up, you really lose efficiency. Danfoss actually shows it on one of their charts. The top end losing efficiency is because, from what I was told, if you don't raise the frequency at the same rate that you're raising the voltage or vice versa, it heats. And Danfoss shows it real well on their units. They got a sample, and I don't believe I have it on this slide set, but they have a sample where at 30 hertz, you got like a 22 EER, which is great. But at 90 hertz, you've got a 9 EER. And that's directly relation to that issue. This selection will depend entirely upon the detailed information pertaining to the compressor. There's no way I can give you any type of selection, but I'm going to go with one that was presented to me and show you that. One example is a compressor that is 15 tons and can't go below 35 hertz. This means the compressor's bottom end is around 8.75 tons. If we don't have the exact tonnage on the chart, you need to find the close one, but not over the estimated tonnage of the compressor. So in this case, it's 7.5 tons. So if you look at our chart, 7.5 tons package is a 410-5, would give you about 5.68 tons of modulation, about 6 tons. So now this unit now has the capacity, additional 5.5 tons of capacity down to around 3.5 tons. In this particular example, the reason they need to get down there farther is because they operate this cooling system at a super, super cold temperature coming off. And the reason they do that, there's a long story, but it's super, super cold. And during certain conditions, the unit will want to shut off, and by the time it comes back on, where it's being delivered to, which actually is in the airplanes, there's issues with humidity, there's issues with a lot of stuff. So they're looking at this, and they're looking at it right now. This is a true example, like I just told you. Now, staying with package units, we now have a package unit with a single circuit and dual compressors. Now, as we do that, we need to determine the size. We see it as a 20-ton package unit with 2 10-ton compressors. The key is that 2 10-ton compressors. Now, to determine the size of the lead compressor, we've got it. It's 10 tons. The stage is a 50%. The lead compressor is determined to be 10 tons. This is a simple selection. Again, we just go to the chart. On the chart, we'll see that 10-ton package, and it's the RCCD 410-5 with some head pressure help. We'll give you 7 tons of modulation. So anyhow, and you look at this, if you happen to have a unit, and there's some manufacturers that does this, that they'll put 3 compressors on a single circuit, and they'll have one that's smaller than the other 2, and that could be your lead compressor. So in that case there, you need to find that smaller compressor, and remember, it's a single circuit. When we start getting into dual circuits or even more than dual circuits, there's a whole lot of stuff that comes up, and we'll be talking about that real fast. Matter of fact, the next slide. But again, it's the smallest compressor that can be on at any one time, at any time by itself. Now, if it's being used in between, then we're good shape. But it's the smallest that can be on. We size it off of that. So let's get an example. If you had I'm just throwing out some numbers, a 10-ton, a 7.5-ton, and a 5-ton, and they were all on the same circuit, and that 5-ton was the lead one on, we'd have to size the valve sizing off of the 5-ton. If it was somewhere in the middle, and let's say the 7.5 was the lead one that came on, we'd have to size it off the 7.5. So sometimes knowing which ones are the sequences is very important, and you're going to find out it's extremely important in some following examples. Now we're going to get in a little bit more complicated situations. We have a package unit, and it actually has dual circuits, and we're going to keep it simple with only one compressor per circuit. So with that, all the standard questions, everything we talked about still applies. Now, what type of evaporator do you have? You have an intertwined. You have a full face. Or, God forbid, do you have a face split evaporator, which one of the major manufacturers has this on a lot of their units. And you need to know if it's face split, and you'll find out more about that. Going to look at each one and see what happens, but the first one's the intertwined. Same 20-ton package unit, but now a difference. We have two 10-ton compressors again. Now an additional question needs to be asked. Does this unit have the capability of lead lag? If not, then all's good. You would look at the 10-ton compressor that is the lead compressor, the one that comes on all the time, the first compressor. And you would size it just like you would normally size it off of a 10-ton compressor as on the chart. But if this is true, and it does have a lead lag system, unfortunately, you're going to need to put two valves on, one on each circuit. And the reason you're going to need it is that whenever it changes to the lag, and that now becomes the lead, you got to have modulation there. Now, there is some good things about it. Whenever you are in full capacity, you basically have modulation from 3 tons to 20 tons with absolutely no gaps. But if it's just a standard unit and there's no lead lag, you'll have 3 to 10, and then you'll have 13 to 20, but you'll have a little bit of a gap. Now that little bit of a gap means absolutely nothing. It really doesn't hurt, but it's a way to tell your customer, okay, the good part is you'll have full but no gaps. Bad thing is we got to put 2 on there. And there's sometimes on units that you will actually put 2 on there. There's a lot of ifs, ands, and buts, and all that will be in another video that I will be working on. Sequencing comes into play when you have more than one circuit. Several types will be explained later. Also, you gotta, I've seen it, situations where it could be as many as 4. And that's usually, those are the really, really, really rare ones. I might see 1 every 2 years, but they're out there. Again, you go to the fast selection chart, pretty simple. Your collected 10-ton package unit, there you go. Now we're going to stay with 20-ton package unit, but now we got the full face coils. Full face coils can be either the same as the previous one, where it's just split the 2 10-ton compressors, 2 circuits, and all that. But normally that's not the case. Normally one coil is larger than the other one, or if the coils are the same size, there's something going on with the compressor sequencing. Now we have to change And now we have a change in compressor sizes. And instead of having two 10 tons, we got two 5-ton compressors on one circuit and a 10-ton on another. Now, sequencing comes into play with this application. The unit could be either 3 or 4 stages. And it's normally, I can't say what it normally is. You got to find out what the sequencing is. You got to ask that hard question. The best way to tell you is that if when in doubt, put it on the circuit that has the largest compressor and match it to that circuit. And in this case, you would put it on the 10-ton circuit. There could be other instances where, because even if that 10-ton, but the 4-stage goes like this, 4-stage staging. And this actually happens, and a manufacturer does this. The 5-ton on, and that's 25% of the capacity. Then they turn the 5-ton off and put the 10-ton on for 50%. Remember, we said lead on, first one on, last one off. Well, in this case here, if we put a valve on the 5-ton, it's going to be out of the system when the 10-ton comes on because the 5-ton's off. Then to get 75%, still leaves the 10-ton on. The 5-ton is brought back on for 75. Then the last 5 tons brought on with all compressors running for 100% capacity. Normally we'd stall it on the first on, last off, like I said, but in this case here, we don't want to stall it on the 5-ton circuit. I've seen people put one on the 5-ton and one on the 10-ton. So you actually have modulation with the 5-ton circuit, and you have modulation when the 10-ton comes on, and you have a lot of modulation. It doesn't need it, because if you got a 20-ton package unit and you're somewhere below 5 tons in capacity on it, you're grossly oversized. Choice is put it on the 10-ton circuit in that it would be on from 50% up, thus giving modulation down to 3 tons. What the thought is there is when that 10-ton comes back on, and as your load declines and it's unloading it, it will unload it past the 5-ton. And the odds are it may not even bring the 5-ton back on. But again, it's with appropriate head pressure. Sequence of operation is critical to selection. Same unit as a 3-stage unit. This could go 2 ways. The first one's the normal way it goes. I've only seen it maybe once. The second way. And 10-ton comes on, then a 5, then a 5. So it's 50, 75, 100. That's normal. That's why I'm saying, when in doubt, put it on the 10-ton. Put it on the larger one. But look at it. Find out the sequencing. Ask questions. The second one is 5-ton, 5-ton, 10-ton. Rare, but it could happen, but it's rare. And normally what they'll do on the 5-ton, 5-ton, 10-ton is 5-ton comes on, then the 10-ton comes on to give you 75%. And it's really strange sequencing. Either way, I would size it for the larger compressor. You're at least 25% with one 5-ton, no matter what. Again, the larger compressor, the 10-ton package unit. That's where I would go. Now, continuing the selection process for the face split coils. Again, starting with a 20-ton package unit. We find out we have split face coils. I got face split either way. Installing RCCD on the first stage will not help. Matter of fact, I know of a case where it was installed on the first stage, and it was because of humidity, and nobody asked about face split coils, and the humidity issue actually increased. And the reason being is without an RCCD on there. And by the way, if you guys don't realize what a split face or face split coil is, it's a coil that only takes up a certain percentage of the airstream, and in this case, 50%. So when you cool down that coil, it's going to start to wet up. And when it wets up, you're going to actually have more airflow over the dead coil, or the one that's not active, than the one that is, because of the static that the coil causes when it's wet. So you will have a big time issue there. Another thing that I've seen, and just seen it recently within the last couple of years, is on one unit, it would actually stratify the air as it's going down the duct system, especially if it's coming straight out of it and there's no way to mix it. And the bottom of the duct is so cold that moisture will condensate on it from inside the building because that duct is reaching dew point. Now you can put the RCCD on that and it won't reach dew point. But what happens is because you're drying it out so much and remixing back up, without an RCCD, you get a little bit more humidity removal, not much, but a little bit. And your humidity issue will actually increase. In this case, you need to do several things. First, you need to install the RCCD per circuit. In other words, no matter what, you need 2 of them. And Train's got some units, Carrier's got some units. They all got some units where they like to use split phase coils. And quite honestly, because they're less expensive. But you'll need to put 2 on there. And this case is going to be 2 of them. But I've actually seen it where there's been 4 phase split or split phase coils in there, and they're just stacked. And you need an RCCD on each circuit, and you need them all turned on at the same time. Second sequence, all circuits need to be activated at the same time. You have no choice. That airstream has to see a full coil that is below the dew point so that it can dehumidify. Anything less than that, then you've got a dead coil above and you're not going to work. Same case goes into a unit that was in Chicago, where it was actually one compressor with multiple coils, and they had some type of a static unloader on it and issues in that. And we ended up having to operate, instead of a 4-stage unit, it was 3 stages. We had to get the first 2 active, so we had full face, full coverage. Third, other controls may be needed, and I will discuss all that in another video. But there's a lot of stuff that you can do to a unit to bring it back in. And if you guys have watched any of the other videos, you'll see a couple examples or one reference letter, and that one reference letter dealt with a convenience store setting on the Gulf of Mexico in Texas, and we was able to get it done. There's a whole lot that you can do to get your building in tune, and you need to know all of it, not part of it. And the RCCD control is only part of the solution. And in a lot of cases, not all, and probably not even 50%, but there's a good amount that the RCCD, along with other products, are needed to get you to where you want to go. Again, being 2-stage equal size compressor, valve is the same, but this time you will need to put 2 RCCD 410-5s in. You look at the 10 tons, and there you are. That's where you're at. So with that said, I want you to think about some things. How does head pressure control affect humidity control? If you've heard me talk, you'll know. When do you need a humidistat? You may put the valve on there, but when might you need a humidistat? And there is a lot of cases where you need humidistat. How does the indoor fan speed control help? In other words, there's a lot of selections that you may need some kind of fan speed matching sequencing within a unit. I talk about that too, and that'll be in another video. How does building pressure have an effect? What do you need for a building pressure? How much static pressure do you need? What is it? Is it a positive pressure or negative pressure? All these controls, all this stuff comes into effect. All this and more. The advanced training for humidity control is going to be something I put on here. There's also going to be an advanced training for setting the control up. All this needs to be done. You need to think of everything that we're dealing with. You need to think of the building as a whole. When I do one-on-one or when I do training, one of the things I present to the person or to the group is this. Your building is a system. You need to think of it as a system. Each package unit is a system. There's groups of units that become a system. If part of the system isn't working, what do? A good example is this. The service tech could be called to an area within a building and they say they're not comfortable. They feel that they're not cooling. He goes and checks that unit and that unit's working fine. What he finds out is that his makeup air unit is not working and it's pumping in humid air. And now the package unit can't handle that humid air that's inside or outside. There's a lot of stuff you need to look at when you're doing this. Conclusions. Know the size of the package unit. If more than one compressor, know the smallest that can be on operating. If more than one compressor, know the number of circuits. If more than one compressor, know the evaporator type. And you found out that's very critical. If more than one compressor, know the sequence of operation of the compressors. I should have had a plural on there. With that, I want to thank you. Hopefully this helps, and it helps everything that you guys are doing out here in the field. And also helps the engineers, it helps everybody. One thing that we forget, that we spend all this time out here gaining knowledge and gaining experience, and we forget to share it, or we're so self-conscious of somebody coming in on top of us, we don't want to share it. So with that, I say goodbye and thank you, and look for more recordings coming up in the future.